Hassler here. I'm going to work through the lesson that we did in class at the board for section 5.3. Today we are going to be looking at three different functions, the f function, the g function, and the h function. Values of f are given in the table. I'm just going to go ahead and circle that. Notice this says f of x instead of y equals. The complete graph of g is shown, so the graph is called g of x. And the rule, or the equation, for the function h is h of x equals x squared minus 5. And again, notice that's just repeated here. Again, this is the same as saying y equals. Okay, it's just that if I have y, and y for each of these different functions, then you wouldn't know which function to use or which function I'm talking about. And so we give them names so that when I say use the g function, you're using the graph. Or if I say use the f function, you're using the table. And so these names just replace the y. Problem 1 says determine the values for f of 5, g of 5, and h of 5. And so recall that if I have that number in parentheses, that's really an x value. All of these 5s represent an x value. And so in f of 5, which is really an x value, that means I want to look at the f table. I want to look at when x is 5, and I want the y answer, so that would be -2. If I'm looking for g of 5, again, I'm looking for where is the x value 5, so that's here on the g graph, and what's the y value associated with the point on the graph. The y value that goes with an x value of 5 is 1. And finally, if I'm finding h of 5, again, 5 is an x value. And so what I'm going to do is I'm going to replace the x in this equation with 5. And so I have 5 squared minus 5, which is really 25 minus 5, which is 20. So h of 5 is 20. And so this is just me practicing finding the output when x is 5 for each of the different representations. And notice they all have different answers because they are not all the same function. All right, 2a says, what values of x does the function g use? What values of x does the function g use? So again, I'm up here at g, and it looks to me like I have points that are plotted. So let me go back and erase some things here. Okay. What values of x? So I'm looking at all the numbers on the x-axis that get used for this graph. For example, an x value of -4 gets used for that graph. An x value of -3 gets used. An x value of -2, -1, 0, an x value of 1, 2, 3, an x value of 4 and 5. All of those are x values that get used for the graph. So notice I have dots there. What I also notice, though, are that there are other parts of this graph that get used, these little line segments in between. And those little line segments are made up of infinitely many points, all of which align with numbers between the ones that I listed, between these integers. This is -2, -1, 0, 1, and 2. And so I can say things like all numbers between -4 and 5 are all the values of x that get used. And so again, I'm going to do this. I'm going to go back to my eraser. I'm going to erase this mess of stuff that I have here. I'm going to clean it up here for you. -4 on the x-axis is the first x value that gets used, all the way up to an x value of 5. That's the last x value that gets used. So I'm kind of like making these borders here, these boundaries, and every number between -4 and 5 on the x-axis got used. Well, listen, we are mathematicians, so we are efficient. I could either write all numbers between -4 and 5, that's 6 words or numbers, or I could use this notation. -4 is the smallest x value used, right? -4 is smaller than all of the other x values, or equal to. I can be equal to that. And all those other x values are smaller than or equal to 5. These two things represent the same idea. And me personally, I would prefer to use this because this is more efficient. It says the same thing. It says I'm using every single x value between -4 and 5. We've seen this notation before. And it's just an easier way to describe that every number between -4 and 5 is used. Let's take a look at B. B says, what values of y does the function g use? So again, when I'm talking about y, I'm talking about things against the y-axis, right? So this first y value that gets used is -2. And in fact, -1 gets used, and 0 gets used, and 1 gets used, a y value of 2, a y value of 3. 4 is the last y value that gets used. So notice that I'm kind of making these boundaries here as well, but it's boundaries against the y-axis. So I could say things like all numbers between, -2 and 4. So all of my y values between -2 and 4 get graphed. If I were to trace out this curve, the lowest y value I use is -2, and the biggest y value I use is 4. But again, I'm a mathematician and I'm going to be efficient. So I'm going to say -2 is the smallest y value. It's smaller than or equal to other y values. I'm going to use this y here. And those y values are all smaller than or equal to 4. 4 is the biggest y value that gets used. And so I can either say all numbers in between, or I can use this mathematical notation. All right, we'll do more with that over the next couple of days with our practices. And so there we go. Let's take a look at 3. One of your classmates makes a claim that the outputs of H will only include positive values, since squaring any number always gives a positive. All right, so I'm going to head back and I'm going to remind you that H of x up at the top is equal to x squared minus 5, so that I can stay in this space. And one of the classmates claimed that only positive values will be my answer. I will only get a positive number out as my answer, because if I square any negative number, it becomes positive. The idea that if I take -2 and square it, that's -2 times -2, which is positive. And so since I square negative numbers, I always get a positive out. Do you agree or disagree? And the discussion we had is that we actually disagree. For example, if I use -2, so if I say h of -2, that means I'm doing, in parentheses, -2 squared minus 5. But -2 squared is, like I said, -2 times -2, so I really get a positive 4. But positive 4 minus 5 is -1. So no, I do not agree. And this is called a counterexample. You came up with an example that goes against their claim, okay? So just because you square negative numbers and make them positive doesn't always mean your answer, your final answer, is positive. That subtraction of 5 could force some of my answers to be negative. Which function after your h has the greatest y-intercept? So again, I'm making a note to myself. Y-intercept occurs when the x value is 0, or when you cross the y-axis. And so I'm looking for when f of 0 is equal to, and if I go back up to my table, f of 0, be right here, f of 0 is 1. I'm looking at g of 0, so g of 0. Well, g is a graph, so I could look at either when x is 0, or where I'm crossing the y-axis means the same thing. The y value is 3. So g of 0 is 3. And h of 0, well, my function for h is this one. And so I would be doing 0 squared minus 5, which is -5. And so which one has the biggest or greatest y-intercept? Well, g does. How do you know? Well, this is my evidence. I showed you what the output was for f, the output for g, the output for h, and 3 is bigger than the other two answers. And finally, problem 5 says f of a equals -2. What is the value of a? All right, so in this case, a is in the spot of my input. This is like saying find x. A just represents a special x. When f of a equals -2, -2, that's my output. that means find x when y equals -2, and we're doing that specifically for the f function. We're going to head back up here. We're going to say, okay, looking at my f function, I'm looking for when the output is -2. Well, we already used this one before. So when my output, f, is -2, the x that goes with that is 5. And so we can say, okay, fine. If f of a equals -2, what's the value of a? A is 5. Okay. In other words, f of 5 would equal that -2. Okay. All right. And so your job is to see what you can do on problem or on the check your understanding. I am going to give you a couple of hints here on the check your understanding. It says for how many values of x is h of x equal to 0? That's the same as saying when y is equal to 0. And when y is 0, you have an x-intercept. E says find the x-intercept of f. Finding an x-intercept means you're looking for when y is 0. Remember, this is the same as saying y equals 2x minus 6. The other thing I'm going to throw at you is down here at 2. 2c says write an equation for g of x. That means write me an equation in that y equals mx plus b form. M, remember, is the slope. The slope is that change in y over change in x. And b is that y-intercept. And so you can use your table to find your change in y over change in x to notice where your y-intercept is and then write an equation from there. And then 3 is that domain and range, so using that interval notation to come up with an interval of x's and an interval of y's. If you have any questions, make sure you let me know.